Hi, this is Pratik and welcome to Code Verify. In this video lesson, we'll learn about pre-order traversal in a binary tree. So in the previous tutorial, I talked about inner traversal in a binary tree, and pre-order is yet another tree traversal techniques. Now let's start with this very similar example that we took in the previous video, and let's do pre-order traversal of this binary tree. So the rule is very similar. So here, pre-order means something you are doing early, and that is you are first printing the root, and then you are moving to the left subtree, and then you are moving to the right subtree. So you see this binary tree. So first you print the root, that is 1, then you move to the left subtree of this entire binary tree, which is this, and then you apply the same rule, that is print the root, which means you print 2, and then you move to the left part again, and this time you move to this innermost subtree, and here you again first print the root, and then now you try to move to the left part of this innermost subtree, but there is no left part, which means now you have to go to the right part. Again, there is no right part, which means you cannot move any further down from 4, which means you move back to its upper tree, which means this tree, and here you have already printed the root, which means now it's time to move to the left part of this tree, which is this. So here again you apply the same rule and you print 5. Now you're done with this tree. Now you have applied printing the root and going to the left and going to the right, which means you're done with this tree. So after you're finished with this tree, you move to this upper tree in which you have already printed 1, and now you have already gone to its left subtree, which means now it's time to go to its right subtree, which is this. So here again you apply the same rule and you come out with printing 3. So the resultant pre-order traversal is 1, 2, 4, 5 and 3. So now let's code this out. So first I'm going to define a class node, and in this class node I'm going to define a constructor which is going to take the node data as parameter. So this constructor basically forms the structure of the node that I will be forming later in this tutorial. So for creating the structure, first I am gonna declare that self.data is node data. So I'm going to take this node data pass as the parameter, and I am gonna put it into this data variable. And after this I am gonna declare the left part as none and the right part also as none. And now I am gonna create the node complete binary tree, so in order to do that, first I have to make an object of the class node so that our basic node structure gets created with a root as 1. So our binary tree gets created and the root of that binary tree will have the data as 1. And if you see this binary tree, its left is 2 and its right is 3. So in order to form the left connection, I have to say root dot left is node with data as 2 and root dot right is the node with data as 3. So I'm going to say that root dot left is node with data as 2 and the root dot right is the node with data as 3. Similarly, I'm going to form the other two nodes, that is root dot left is the node with data as 4 and the root dot left dot right is the node with data as 5. So 4 and 5 are going to get attached with the node with data as 2. So after doing this, I finally got the binary tree, and now I am going to define a function called preorder, and this preorder function is going to take the root as the parameter, that is the node with data as 1. And now I am going to check that if root, that whatever is passed as the parameter to this function, if it is not none. So basically if I say if root, it means that I'm checking if root is not none. Alright, so if root passed is not none, then remember the rule. So first we are going to print the root's data, and after printing the root's data I'm going to move to the left part of this binary tree, and that I can do by recursively calling the function again and passing the root dot left as the parameter. Now in this left subtree I again have to continue with the same rule. So I'm gonna recursively call this function here, and again this function will run from the beginning and start applying the rule from the beginning. Now after moving to the left part, it's time to move to the right part, and that I can do by recursively calling the function again and passing the root dot right as the parameter. So now let's try to visualize how this entire thing works. And after doing all these things, I'm gonna call this preorder function in the main. So I can call this by saying preorder and pass the root, that is the root of this entire binary tree. So now let's try to visualize. So the first time this function preorder runs in the main, and each of these block represents the function call. The first uppermost block is the call in the main. So first time this function gets called in the main, the parameter passed to it is the node with data as 1, which is the root of this entire binary tree, which means the function runs and it checks if root, yes, root is not none, and in this case it prints the root's data, which means in this function 1 gets printed. And after this, I recursively call the function again and this time pass root dot left as the parameter to this function, which means the function again reruns. And now when it reruns from the beginning, and the first thing it does, it checks if root. So yes, root dot left is this node with data as 2 and it is not none. So in this case, if root is not none, then first it's gonna do is that it's gonna print the root's data. So the parameter passed to it was 2 and it will print the root's data, that is 2. And after this, it's again gonna call itself recursively, and this time it's gonna pass 2's left, that is the node with data as 4 as the parameter. So the function gets called again, and this time the node with data 4 is passed as the parameter, and after that it checks if root is not, if the parameter that is passed is none or not. So here 4 is not none, all right, which means now it's gonna print the parameters data. So the parameters data is 4, which means it's gonna print 4. And after printing 4, it's again gonna call itself recursively, and this time when it calls itself recursively, it passes 4's left as the parameter. So 4's left here is none, which means you pass none as the parameter to this innermost called function. And when none is passed as a parameter, so first thing that the function does is check if the parameter passed to is none or not. So here root becomes none, which means this function is not gonna execute these 3 steps. And when it cannot execute these 3 steps, which means it is done with itself, and in this case it will return the authority to its upper caller function, which is this. And then in this upper caller function, in which the parameter is the node with data as 4, and in this upper caller function it has already executed the print statement. It has recursively called for its left part, which means the only thing left with this upper call function is executing the recursive function for its right part, which means now it's going to recursively call its right part, and 4's right is also none. So the story will be same as it happened for this innermost function. So again, since none is passed as parameter to this function will not execute the 3 steps, which means it will again return its authority to its upper caller function, which is this. Now in this upper caller function, it has done executing all these 3 steps, which means it has finally done with itself, which means now this function is simply gonna return its authority to its upper caller function, which is the function with parameter as the node with data as 2. Now in this upper caller function, it sees that it has already printed its data and it has done with recursively calling its left part, which means the only thing left is recursively calling its right part, which means now this function makes a recursive call to its right part and passes the node with data as 5 as the parameter to this function. Now when the node with data as 5 is passed to this function, it again reruns, and first thing it does is check if the parameter passed to is none or not. So in this case, the parameter passed to is not none, which means it's gonna execute all these 3 steps. The first step is printing its data. So 5 gets printed here, and when 5 gets printed here, the second step is recursively call for its left part. Now it recursively calls its left part and it passes 5's left as parameter, which means none is passed as the parameter because 5's left is none and 5's right is also none. So 5's left is none, which means none is passed as a parameter in this innermost calling function. And since none is passed as a parameter, which means all the 3 steps, that is printing the roots data and going to the left and right, all these 3 steps will not take place, which means the authority is returned back to this upper caller function with node data as 5. And now in this function, it has already done printing its roots data, it has already done recursively calling its left, and now it's time to recursively call its right. Now when it recursively calls its right, again the same thing happens. 5's right is none, which means none will be passed to that recursively called function, and since none would be passed there, which means again the authority will come back to 5. And when the authority comes back to 5, the function is going to see that it has already executed all its 3 steps, which means now it is going to return its authority to its upper caller function with node with data as 2. And now when authority comes back to this function, it sees that it has done executing all these 3 steps, which means it has done executing itself, which means this function is going to return its authority to its upper caller function with the node as data 1. Now when we come back to this upper caller function, we see that we have already done with printing the data and we have done with recursively calling its left part, and now it's time to recursively call its right part. And when we recursively call its right part, then in this function the parameter passed to is the node with data as 3, and the first thing this function is going to do is print. So after checking if the parameter pass is none or not, so parameter pass is definitely not none, so after the first thing it's going to do is print its data, which is 3, and after printing 3, it's going to recursively call its left part. And when it recursively calls its left part, the parameter passed to this innermost function is none because 3's left is none, and when none is passed here and the function runs, it's going to check if the parameter is none or not. Here the parameter is none, which means all the 3 steps will not execute, and in this case it's going to return the authority back to its upper caller function. The authority comes back to the upper caller function and it tries to run the 3rd step, that is recursively calling the right part. The story goes same with the right part also, because the parameter passed to this right part is again none, which means it's again gonna return the authority back to its upper caller function. Now back to its upper caller function, it sees that it has already executed all these 3 steps, which means it has done with executing itself, which means now this function is gonna return its authority to this function. So back to this function, it sees that it has also finished executing all these 3 steps, which means the overall function executing is over and we are done with everything. So now it's time to run this function. So I save this and I run this. So here it would be preorder, because the in order was the previous tutorial and here it is preorder. All right, so I am going to run this and I see the following result: 1 2 4 5 3, which is the resultant output that we were supposed to get. So I hope that you understood this video. Like and share this video and subscribe to the channel.